Welcome to the channel. Coming back to 10,000 kilometer speedometer endurance test, our today's discussion includes some very important and critical recommendations and a quality assurance checklist related to speedometer testing procedure. The topic includes number one, critical recommendations. Number two, quality assurance checklist, including calibration and accuracy, real-world usage simulation, environmental response and exposure, electrical voltage testing for digital speedometer only, mechanical stress testing, temperature impact monitoring, ingress protection testing, speedometer tamper resistance, serviceability and repair testing, user's own perception and ergonomics, redundancy and multi-unit testing, a special note on cockpit heat, and finally, introduction to the next topic. Here are important technical and practical recommendations to ensure that 10,000 kilometer endurance road test of motorcycle speedometer yields meaningful and reliable results and captures hidden or long-term issues. Number one, use a reference GPS logger throughout the test. Equip the test motorcycle with a high accuracy GPS data logger that helps catch any gradual speed or distance drift that may not be obvious in daily riding. Number two, simulate real-world abuse conditions. Do not just ride normally. Simulate conditions like sudden braking and acceleration to test lag and response. Frequent water splashes or riding through puddles to check water resistance. Off-road vibrations to test mounting integrity, needle flutter, or PCB fatigue. Night riding to test backlight durability. Number three, vibration and shock testing on the road. Monitor as to how continuous vibration from the rough roads affect needle stability and cable retention capability of analog speedometer. Digital pixel stability and connector contact quality of digital speedometer. You can optionally mount a vibration logger to correlate failures with mechanical shocks. Number 4. Thermal exposure logging. Ensure exposure to temperature cycles from cold morning starts, say 5 degrees centigrade or lower, midday highway rides up to 45 degrees centigrade. Use a thermometer logger near the speedometer to record actual temperature variation. Digital displays on the digital speedometer can behave erratically if exposed to prolonged heat, especially LCD-based one. Number 5. Ingress protection verification. Simulate rain spray. Use water hose for consistency. Dust clouds, especially during off-road runs. Then inspect for dust behind the needle, any fogging under lens for analog speedometer, and moisture under display and corrosion on printed circuit board for digital speedometer. Number 6. Record voltage variation effects. This is especially important for digital units which rely on stable power. Run the test with weak battery, that is simulate low voltage, cranking cycles. Use electrical loads, that is switch on headlight, horn to simulate voltage drops. Check if speedometer resets, freezes, or shows glitches. Number 7. Test odometer fraud resistance. Try disconnecting and reconnecting sensor or battery mid-ride and see, does the digital unit maintain odometer integrity? Some low-cost units can roll back or freeze when tampered with. Number 8. Serviceability assessment. After completion of 10,000 kilometers, evaluate as to times and tools required to remove and repair. Are analog cable easily replaceable? Can the digital display be removed without damaging connectors? Please remember, good test reports don't just measure performance, they comment on maintainability too. Number 9. Evaluate users' own perception. Include riders' feedback. Is the analog speedometer legible at a glance at higher speed? Does the digital speedometer wash out in sunlight or glare is observed at night? Any annoying buzzing or clicking sounds from analog units? Number 10. Use redundancy. That is, test multiple units. To rule out single unit defects, run the test on 3 to 5 units of each type if possible. 10,000 kilometer speeder endurance test. Here is complete quality assurance checklist. Number 1, checklist related to calibration and accuracy. Check whether GPS speed logger installed and it is functional. Ensure pre-test calibration. It is performed at 20 km, 20 to 100 km per hour range. Mid-test calibration at 5,000 km completion of endurance test. Post-test calibration at 10,000 km, that is the completion of test. Odometer reading accuracy is logged regularly or not. Real-world usage simulation. Test conditions. City riding conditions. That is for the purpose of start, stop, and short burst. Highway cruising is simulated. That is for the purpose of steady speed and high load. Off-road conditions are tested to check vibration and dust. Ride on mountain and hilly terrain is included. That is to check gear changes and slopes. The test is conducted with the payload variation, that is solo and with pillion and luggage. Environmental exposure. Test is conducted in hot conditions, that is more than 40 degrees centigrade temperature. Test is conducted in cold environment, that is less than 10 degrees centigrade condition. Rain exposure is simulated or naturally encountered. Dust and cloud exposure are simulated. Nighttime readability is evaluated. The checklist point related to electrical voltage and testing applicable to digital speedometer. That is, low battery operation is tested. Sudden engine cranking is tested or not for voltage dip response. High electrical load is tested when the lights are on and horn is operative. Speedometer response to unstable voltage is logged. Mechanical stress testing, that is, sudden acceleration and braking are simulated. High vibrations roads are tested. Repeated bumps and potholes conditions are logged. Handlebar mounted speedometer stability is verified. Temperature impact monitoring. Temperature logger placed near speedometer. Maximum minimum temperature exposure has been logged. Display needle behavior in cold start is tested. Display contrast and response in heat is also tested. Quality assurance checklist related to ingress protection testing items. Number 1. Rain spray or hose test is performed. Dust chamber or heavy dusty road test is conducted. Heavy dust road is conducted. Fogging observed inside analog dial speedometer, if any. Moisture signs on digital display or connectors are observed, if any. Tamper resistance, especially of digital speedometer. Sensor disconnection tested, detects or ignores. Battery removal mid-ride tested. Odometer fraud resistance is checked. Serviceability and repair testing. Record time taken to remove analog cable. Ease of digital display removal is noted. Connector access and protection is inspected. And availability of spare part is evaluated. Checklist item, quality assurance checklist item related to user perception and ergonomics. Analog readability at higher speed, evaluated or not. Digital screen readability in sunlight and night is tested or not. Any mechanical noise or rattle from analog dial has been recorded or not. Any flicker, lag or delay in digital display has been observed or not. And finally, to ensure that the test results are reliable, multi-unit testing is recommended, which is very important. Test or check whether more than one unit are tested. Consistency across units has been evaluated. Any unit-specific anomalies have been recorded or not. As we have already discussed, that the cockpit heat is the accumulated thermal load or temperature exposure that the system has to endure due to sunlight radiation, ambient outdoor heat, engine or radiator heat conduction, and lack of ventilation around the system or cluster. Why it matters in 10,000 kilometer test? Because the test checks reliability, accuracy, and durability of the speedometer system under the real-world stress conditions, including the following. Number 1, material durability. Prolonged heat can cause plastic deformation, color fading, or warping of meter housing. LCD or LED performance. Due to extensive heat, LCD may fade or become unreliable at higher temperatures. Segment failures may also appear. Sensor reliability. Heat affects sensor accuracy, especially magnet or optical sensors. Electronic performance in general, that is, integrated circuit and PCBs, may suffer thermal expansion, leading to solder crack, failures, or a component drift. Adhesive degradation, that is, tapes, glues, or mounting fixture, may weaken under heat exposure. Typical cockpit heat ranges. Number 1, normal ambient from 25 degree to 35 degree centigrade. Number 2, cockpit under sun from a temperature 55 to 85 degree centigrade, and it can exceed 90 degree centigrade in tropical or what we can say hot countries. The test standards in some of the OEMs consider 85 degree centigrade for continuous exposure tests. Testing example. To simulate cockpit heat, test environments may include parked vehicle under sunlight for hours before driving, wind tunnel with heaters or thermal chambers, heated test rigs with sensors measuring actual temperature near the speedometer. The recommended countermeasures for a cockpit heat are use of ultraviolet stabilized plastic and heat resistance adhesive to manufacture speedometer. Heat shielding inside dashboard, vented design for better air circulation, choosing LCD or PCBs rated for higher temperature operation. With this, we conclude our discussion on the subject of 10,000 kilometer speedometer endurance test. Please do drop your comments and share your experience to further improve the contents of this channel. Our next topic of discussion would be speedometer cable quality check test. Thank you and thank you very much.